Got a face for radio, as they say. Okay, so this video is going to be about the concept of limiting reactant. So it's going to build on some of the calculations where we take grams of one of the reactants, 2 grams of product, but with a little bit of a twist. And so the analogy I'm going to use is like pieces of bread and a sandwich, and slice of cheese to make the sandwich. So if you just buy a random loaf of bread and a random package of sliced cheese, odds are that you're not going to use up every one of those in order to make a sandwich, that you'll have either some leftover bread or some leftover cheese. The other thing is, it has nothing to do with the weight of the bread or the cheese either. And so first thing we're going to have to do is convert the mass of these things to actually the number of these things. That's what determines how many sandwiches we can make. And so the example we're going to use has exactly the same stoichiometry as making a sandwich. Okay, and so the example we're going to have is carbon monoxide. Okay, and it's going to react with 2 hydrogens, also a gas, and it's going to form a methanol. Okay, wood alcohol, which could be in the gas phase when they're actually making this. But notice the stoichiometry. This is like 1 slice of cheese and 2 slices of bread to make 1 sandwich. Okay, so the first thing to realize is that let's do some quantities. Let's say we have 3 moles of this stuff, right? And we have 2 moles of this. Now, the reason these numbers have nothing at all to do with the balanced reaction. So these numbers have no relationship to the actual quantities you might have. Just because you have 2 slices of bread in a sandwich doesn't mean that you're going to have 2 slices of bread for every slice of cheese that you buy. All right, so let's just say we bought 3 slices of cheese, and this example will work better if we do 4 moles. All right, so we'll do 4 moles. See, these numbers had nothing to do with these numbers, didn't they? I just changed that number. Now let's say we have 3 and 4. All right, so the first thing we do is we figure out, if we have 3 slices of cheese, how many sandwiches can we make with 1 slice per sandwich? And so 3 moles of CO, and then there's a conversion factor, 1 mole of CO, 1 mole of the product. And that's that. And we can make 3 moles of the product. Okay, so that's how much we can make with the cheese we have, or the CO. All right, let's say we have 4 slices of bread, or 4 moles of H2. 4.0 moles of H2 it requires 2 moles of H2 for every sandwich or methanol molecule, whatever. All right, and so we can make 2 moles of methanol. So we have enough bread to make 2 sandwiches. We have enough cheese to make 3 sandwiches. Well, how many sandwiches can you make? Well, you can only make 2 sandwiches. All right, and so you take the smallest amount. So basically what we do is we're given the amount of 2 reactants. That's the key that tells us we're having a limiting reactant problem. If you're given the amount of 1 reactant, we always assume there's enough of the other. But if you're given the amount of 2 reactants, then you think, I've got to take each reactant and convert it to the amount of product I can make from that reactant. And the one that's the smallest is the amount I actually can make, because I'm going to run out of that one. And of course, we could actually, in principle, figure out how much leftover carbon monoxide we have, but that's a more difficult problem. All right, so that's the concept of limiting reactant in a nutshell. Next video is going to do numerical example where we have to convert grams to moles, and then after that we're going to do percent yield.